ASRock makes two M.2 by 16 cards. Today we're going to take a look at one of them. ASRock makes the Ultra Quad M.2 and the Hyper Quad M.2. What's the difference? The Ultra Quad is PCI Express Generation 3 and the Hyper Quad is PCI Express Generation 4. So what's the big difference? Well, that's what we want to establish, because we're going to take a look at this with the drives like we've done with the other cards of the different brands we've looked at from ASUS and also from Gigabyte. This is number 3, because what I'm eager to get to is card number 4, a card you've probably never heard of by Amphitech called the Squid that uses 6 drives. But we got to do this first, because I think this is in some way a superior product to what ASUS has. And the reason I say that is because, remember, ASRock got their start creating OEM motherboards for ASUS. So we're going to do our 4 things. We'll do an unboxing, inspection, installation, and test. And we're also going to take a look at our chart. And the only thing I'm going to refer to in this chart, if you want to see how all this relates and understand it, look at the previous video. We're going to look at the ASUS, we're going to look at the Gigabyte, and now we're going to take a look at ASRock. Now for the unboxing. This box is not sealed, and we've been trying to get to this for a very long time, but we've been busy answering subscriber questions. So now we're getting to this one. And the design is going to look very similar to the ASUS. Go figure that. So we've got the M.2 by 16 card. We have an extra screw in the package. We have a driver CD. And the driver CD will clarify that. It's not actually a driver. What this actually is the application for the fan to control that fan, so you can put in multiple cards in a machine. 2 standoff screws and 3 standoff screws. Let's hope the 4th standoff screw is on the M.2 card. If it's not, we got a problem. So we'll just set the box aside for the moment. And this also had a little package in it, package contents. Let's take a look at that. Aha, I found the other screw. It was tucked in the back of the package. So that's our 4 screws we're going to need to secure the drives with. Outstanding. ASRock Ultra Quad, and remember it's the Ultra versus Hyper. This is PCI Express 3, but we are going to use PCI Express 4.0 drives, because there's 3 things that determine the speed. 1, the motherboard chipset. Number 2, the speed of the memory. And number 3, the M.2 card, if it has a PLX chip. This does not have a PLX chip, but the next video coming up does have a PLX chip. So again, to reiterate, PCI Express 4.0 drives are going on here. We'll use the same ones we had in the last test. And if you look here at the charts on the right, top on the ASUS, second on the Gigabyte, both use 1 through 4, Sabre Rocket 4 drives, and those are PCI Express 4.0 first generation. We then take the 1 and 2 drives out and replace it with 5 and 6, which is the WD Black SN850 and the Samsung 980 Pro, of which both of those 2 drives have had firmware updates. The WD Black SN850 had to. The Samsung 980 Pro did not have to, but we did, so that we could restore performance on the Gigabyte card where we ran into a problem, and I'm not going to go into those details. You can read about it in the previous video. So again, let's look at the contents. The ASRock Ultra Quad M.2 card, quick installation guide, support CD, M.2 screws, of which, yes, we found our 4 screws. Specifications on dimensions, the interface. This requires PCI Express 3.0 by 16. And to make this work, that slot has to be bifurcated. That's not just by 16 mechanically, that's by 16 electrically. Connector, 4 Ultra M.2 sockets, supports and the type 2242, 2260, 2280, of which we will be using in 22110. And it says Generation 3, 4 lanes for each drive. And again, to reiterate, we're going to use Generation 4 drives. And what I like about this card that does not appear on others, it has the graphics 12-volt power connector. And that's always been a concern. Are we getting enough power to all the drives? And there's a list of supported motherboards. Now at the time this was printed, this was for X299. And it also works on the X399. Specifically on ASRock motherboards, generically on those chipsets. And the uniqueness of the platform we're working on is PCI Express 4.0. This is the Gigabyte TRX40 Designaire, where we have 2 16-lane slots and 2 8-lane slots. And we're going to use the primary 16-lane slot for this card with those 4 drives, of which we'll swap out 2. So we'll do 2 sets of tests. I like this instruction sheet. I think this is nice. We'll have 5 screws to remove. We have to separate the PCB from the heat sink. Then we're going to have 4 thermal pads with protective covers that we'll remove that are already pre-applied. We'll use the stock. And yes, if we wanted to improve the performance, we could do two things. One, change out the thermal pads, and two, remove the labels on the drives. And no, we do not remove labels on the drives, or else we wouldn't know who's on first. It's for clarity that we keep those labels on, but that's your choice. Then we install the card, and then card layout. And we have a card fan switch, and to reiterate, a power connector. Now on the back side, the ASRock utility control switch, switch 1 and switch 2. The card fan switch. Use this switch to control the card fan speed. Off, on, the fan runs at half speed with a half voltage supply. And the graphics 12-volt power connector, also known as the PEG, PCI Express graphics connector. This card provides a 6-pin graphics 12-volt power connector. Install the power supplies cable to this connector when more than 2 M.2 cards are installed. And an M.2 card meaning the memory, the M.2 NVMe drives. And it specifies here Intel Optane SSD 900P or other M.2 card with a higher power consumption. Installing the modules, talks about the length, spacing of the screws, gives nut location PCB length module type. Discussions about moving the standoff. The default is usually 2280, and that's where we're going, and about swapping them out. Demonstrates the installation of the drives, secure the fastener, and the last part is about the UltraQuad M.2 card utility. With this utility, the UltraQuad M.2 card, we can check to see the drive is properly installed and adjust the fan speed. Just place the support CD in the drive, run the utility, or download it from the ASRock website if you don't have a CD. All the M.2 cards have different software on handling these drives. We haven't pointed out the utility software before for controlling these fans because they're off or on. And the primary fan that we think is the most problem, to reiterate that fact, is the MOSFET fan on the motherboard where that coil whine occurs. I don't think these fans, even though they're too small, they should be larger. And MSI on their expander, which we won't get a chance to look at unless somebody sends us one because you can't buy it by itself. And it looks like a nice little video card with a great big fan on it. They were the first MSI to have a large fan on that. Okay, Gigabyte now on their new Gigabyte Aorus Extreme has a couple of nice big fans, but it's going to accommodate 8 drives. So this little bitty fan will do the job, on or off. If it's a problem, turn it off. No software necessary. If you want to turn it on, turn it on. And to turn it off, unplug it. You don't need software for that. So as far as the software being really useful, I don't like anything on a machine that is extemporaneous, and I consider software like that extemporaneous. So let's go back to the card. So much for the instruction sheet, but I appreciate that. And I appreciate the CD with the software for the fan control. Now what matters? Let's see what we've got. And that's the ASRock UltraQuad M.2/16. Just for a quick glance, see if I can get all 3 of these up here on the table where y'all can see these. Since a picture is worth 1,000 words, these two are PCI Express 3.0, whereas these two are PCI Express 4.0. PCI Express 4.0 cards are just a little bit longer. Not necessarily required, but they are. They all 4 use a 16-lane slot, and they all 4 do not have a PLX chip. They all 4 therefore should be able to get the same speed. Only the ASRock has a power tap on it. The other ASUS, of which there are actually 2, but I just wanted to fit these 4 in the screen, these other 3 do not have power taps. You would think because of the PCI Express 4.0 speed, there would be power taps on here. That's why I wanted to show this ASRock last, because even though that's PCI Express 3 and there's a PCI Express 4.0 version, I think ASRock has a superior design, but we need to see what kind of speed we get on the test, what kind of heat we get. But I wanted to show you that because I think it's kind of fascinating. Again, to reiterate, ASUS PCI Express 3, ASRock PCI Express 3, ASUS PCI Express 4, and Gigabyte PCI Express 4. And of course the black tape is for the thermal emissivity readings we were working on with the FLIR camera. So the only comparison we'll make now going forward will be with the one that has the memory, which happens to be the Gigabyte, and we'll get these other 2 out of the way. The other 2 being the 2 by ASUS. And for the question that comes up, have you ever put 4 of these in a machine? I'll repeat what I've said before. No, we have not. We have to build a WRX-80. We're still waiting to get all the parts for that. And we have to have, remember, 4 16-lane slots. The TRX-40 only has 2 16-lane slots. So to have 4 cards, 4 of these cards that each require a 16-lane slot, got to have a workstation, which is beyond a high-end desktop. I need to also mention that the ASUS card had a switch on the rear where you could turn the fans off and on for what it was worth on the outside on the back I/O panel, where the ASRock does not. and the Gigabyte does not. And Asus had that on both their PCI Express 3 and PCI Express 4.0 card. Detail: 5 screws to remove, and that requires a number 1 Phillips tip. And those screws have had Loctite blue. Keeps them secure, but does not prevent us from removing them with a good screwdriver. I mention that because I don't remember seeing that on any of the other cards. Okay, now we can take off the heat sink, turn that back over. Let's see how it looks. That design should look very familiar. A similar little bitty fan. Oh, and I hadn't noticed this. This fan actually has an on-off switch, so it can be, you don't have to just unplug it here on the right. And right now it's in the off position. So we're going to put it in the on position. And there's our power tap, which is a 6-pin. If this were on the motherboard, to reiterate, it'd be called a PEG connector. But because it's on the card, it shows here it's a power 12 volt. So that'll be straight from the power supply. And here's the layout for the switches. And there's also a set of jumper pins here, identified as ICPI. 5 volt, ICP DA, IPC CK, ICRST, and ground. And the switch bank for the system management bus to identify for software which card you'd be looking at if you used it. Nice big labels on the connectors, but even though they're identified as Ultra M.2, meaning PCI Express 3.0, there's no clarity here from reading this as which is 1, 2, 3, and 4. Ah, here it is. Tiny little print. So we're labeled 1 through 4 from the rear I/O panel forward. Number 1, number 2, number 3, and number 4. Does that seem odd, or is that just me? Looks like they'd have made that large enough where you could have easily read it. But now we've got just an I/O panel, a PCB. There's no stiffener on the back like we had with Gigabyte. So who's got the superior design? Depends on what part you're looking at. From a heatsink thermal standpoint, I think Gigabyte has the best design. The best results we've seen so far was with the Asus. But I like the way ASRock has designed and laid theirs out. I like the power tap. I think that's a smart decision. I like the fact that they've got a switch there to turn that off and on. I like the fact that they've got the switches for identifying, if you want, the card for the software, so you can put 4 of these in a machine. The one thing that they should do with their stencil, it's great that identifies Ultra M.2, but that should say connector 1 through 4. Big enough where you could see it without doing what I had to do, because otherwise you need a magnifying glass. Let's go back. And then of course we have our 4 thermal pads, full length. And this heat sink is metal, but the actual heat sink is an aluminum plate, just a plain old aluminum plate with thermal pads, and this is metal. So we'll see what kind of effect that has. And of course our standoffs are already established, and if we had to move those, that looks like that requires a 5mm socket. And this card would be ideal because of the height clearance of these standoffs with double-sided memory. And that has the best clearance of all 3 cards. So this would be my first candidate for double-sided memory. And I believe the Seagate FireCuda 530 is double-sided from what I've read. Till we get our hands on one, I don't know. Now we need to get the memory off the Gigabyte card and go to the next step. I always find it fascinating to look at how different vendors approach the same technology topic with different designs, each with some uniqueness. From a user standpoint, it's kind of fascinating, but really what matters is from a practicality standpoint, it's functionality. How well does the product perform the task? Who has the superior product? I really expected the Gigabyte Aorus M.2 16 quad card to perform the best, and I was surprised that we got better temps with the Asus Hyper. Remember, the Gigabyte had a copper heatsink. Didn't help. And the ASRock has the most simplistic thermal design of any of them. So we'll see. If I were picking one just based on design, it'd be the Gigabyte. I like the metal backplane. I like the copper heatsink. Instead of thermal pads, it has a thermal, instead of thermal pad strips, it's got one large thermal pad over the copper heatsink and also under the drives, which is amazing. But it didn't get as good a temps. Changing out the thermal pads should help that. So I'm really curious to see ASRock's design, how it measures up. We'll see. And I'll have the information up on this card as well as the others that we've talked about in previous videos. I'll have those up in the description. Now, ASRock says that this cover is aluminum. So an aluminum cover with an aluminum heat sink. Okay. Now it says the cooling fan is adjustable. On or off, I don't call adjustable. The shortest trace design, and that was something I wanted to show with this particular card because this is PCI Express 3.0. ASRock had this design for close proximity to the edge connector and at an angle like this before ASUS did. ASUS came out with this on the PCI Express 4. This is ASRock on PCI Express 3. Will it matter? I don't know. Remember, it's about heat and speed. We'll find out. But I wanted to point it out. And the support list on the documentation has grown with the motherboard support list on the website. But again, to reiterate, it's all about ASRock. This card generically will work on X299, X399, TRX40, and WRX80. But if you're on X299 and X399, you're PCI Express 3. If you want PCI Express 4, you're on TRX40, like we're on right now, or you're on a WRX80 for PCI Express 4. That's what we're going to find out, how it's going to test out. The paper document that we looked at previously is the manual, but I went ahead and downloaded the PDF manual because there's one little thing I want to double check here, and that's number 4 right up here in the top right corner. And that's the card fan switch. And this was turned off. And that's what I wanted to verify. That was my expectation right there. So I've turned it on so that fan will be on. We'll see how noisy it gets. Okay, memory. I store the 2 spare drives, the other 2 drives, on the Supermicro Dual M.2 NVMe adapter. Okay, we're through with the Gigabyte adapter. Okay, we have our 4 drives now and the 4 standoff screws. Let's get a close-up on that. I think part numbers are nice to have, just in case if you ever had to order any more. And that's for the standoff screws right there, and that's the part number. And these are Ziploc bags, which is unusual and nice. Everybody else uses a sealed bag. And to reiterate, we found all three pretty quickly in the box. The 4th one was stuck in the back of the packaging of the anti-static bag. So I emphasize that, so if you're having trouble finding or locating one, look carefully. And know the box was not sealed, which I was kind of surprised. But now once this is installed, we do not need to go into the BIOS to check bifurcation. That's already set. But we will go into the BIOS to check the drives, see that they're recognized. I'm going through that in my head about the software that recognizes the drives. Well, that's redundant and extemporaneous. One, if the hardware sees it, which it needs to, then the operating system will see it, which it needs to. I don't need extemporaneous software to tell me that. I'm just pointing that out. So let's get all 4 of these secure. These screws have a nice big head on them, but they have a very short thread on them. What I don't like on this last drive is the close proximity to that fan. It clears, but man, that's close. And there's a piece of tape underneath. I'll pull that off and show you the wires for that fan to keep them out of the way. But that is mighty close. It clears, but you could not put a larger fan on there if you wanted to. Now that's drive 4. Will we get a better temp on drive 4? We had good temps across all 4 drives on the ASUS, but on the Gigabyte, we had a higher temps on the first 2 drives. First 2 drives meaning when we got the WD Black SN850 and the Samsung 980 Pro. Those 2 drives read higher, but they were in positions 1 and 2, replacing the Sabrent Rocket 4. So first test, first assembly, 4 of the Sabrent Rocket 4, PCI Express 4.0, first generation, 5,000 megabytes per drive. We're not going to do anything with RAID, no configuration RAID. We're just using strictly I/O card, keeping the test configuration assembly similar to what we've already done. If we need to do something with this with RAID, separate video. 4 drives are on and secure. Now we need to take a look at our cover and remove the protective covers on the thermal pads, and I will save all 4 of those. I appreciate the long leader they put on there. Makes it a whole lot easier. 1, 2, 3, and 4. Flip that over. Okay, all 4 drives are secure. Fan is turned on. The wire is secured out of the way from that last drive, and we got to find a power tap. And we have our 5 screws secured. ASRock Ultra Quad M.2 card. Power tap, fan, back end is enclosed, so air will come out this end. And there's also LEDs in here where we'll be able to see drive activity if we're looking at it. And we'll take the Supermicro Dual M.2 NVMe adapter and set that aside. Assembly is complete. Now for installation. And we'll be in the primary 16-lane slot right up next to the CPU. That front tab on the I/O panel was bent back a little bit, so I had to bend it out. Yep. Okay, we're in the primary 16-lane slot. We're one slot wide. Our secondary 16-lane slot, 2 slots wide, is an EVGA RTX 2080 Ti. 2 8-lane slots. Second one's occupied. Primary is not. And the connection down here, which is the number 2 spot on the M.2 connector on the motherboard, is also not occupied. And that is a Titan Ridge Thunderbolt 3 card right there. 3 things we're going to be looking at with power on, power to the video. We'll see the BIOS postcodes here. And up here, we have a PC speaker that you cannot see that we will hear post power on self-test. Now we need a power tap. Since we don't need power to the Titan Ridge Thunderbolt 3 card, I'm going to remove those power taps, plug one in over here. That'll do the job just for the test. Quick system check, everything's plugged in secure. We'll plug in power, turn it on, energize, power to the video card, postcodes, we'll hear post. We'll go into the BIOS right after post. We want to verify our 4 drives on that card. I'll tab over to boot, and there's the boot drive, the Seagate Fire CUDA 520, which is on the motherboard, which is on the primary connector right here, that heatsink underneath the quad card to the CPU. Number 2 that has nothing on it, also to the CPU. And the other 2 M.2 drives that are under one heatsink, those 2 are through the chipset. And the 4 drives on the quad card, Sabrent Rocket 4.0, 2 terabyte, 1, 2, 3, and 4. All we need to do is F10, save, reboot. We'll go through post again. We verified drives are seen and recognized. We'll go into Windows and we'll get our 2 tests up. Hardware info on the left. We're going to be looking at sensors only. As long as the drives are not in RAID, we'll have smart telemetry. And on the right, we'll see the speed. We'll check our results. And for those interested, we get asked this a lot. Humidity is 47% and the temperature is 82 degrees Fahrenheit. So you can extrapolate that for Celsius. We'll go to Windows. The drives popped up. 2 of them did. So first thing we'll do is verify Windows flag E, this PC. We'll go to Explorer and we see disk 1, 2, 3, and 4. And we'll test them accordingly. D, F, G, and H. Hardware info, sensors only. We'll scroll down to our drives. Okay, there's the boot drive, Seagate Fire CUDA 520. And here are the Sabrent Rockets, 1, 2, 3, and 4. So let's get this where we can see all 4 of them. There we are. And we're going to go through all 4 of these and test. Crystal Disk Mark. We'll start with drive D. 2 terabyte drive, 2 gigabyte test file, all. Highlight. And our minimum is 33, so we're looking at minimum, maximum, and average. Let's see how hot they get. Fantastic. First test completed. We started at 33 degrees, cold boot. We hit 51 degrees, so we're a little bit hotter. We've established, first of all, the card is PCI Express 3.0. And if you notice, our read speed is 5,000 megabytes, which establishes the Sabrent Rocket 4.0 is PCI Express 4.0 first generation. So again, the 3 things that control speed: 1, the motherboard chipset; number 2, the speed of the drives; and number 3, if there's a PLX chip, which we do not have on this card. So whether it's sold as PCI Express 3 or sold as PCI Express 4, it works, the I/O card that is, according to the speed of the drives and the chipset. Okay, that slot that we are on in the primary slot is a slot. In fact, all the slots on the TRX 40 are directly to the CPU. They're not going through the chipset. So no degradation in performance. And our hottest temperature was on the second number of the megabytes on the right. And that's when we got to 51. And how that compares on the chart, that drive on the other 2 cards was at 49 degrees. 49 degrees on the Asus Hyper M.2 and 49 degrees on the Sabrent Rocket. Now we've got to go through the other 3 drives so we'll know what all 4 drives test out as they compare to these other 2 charts. Then we'll swap out for the other 2 drives that are PCI Express 4.0 second generation and see how those temps compare. Drive F, 2 terabyte, 2 gigabyte test file, all. And we will highlight the second drive. Now to remind everybody, on the other 2 cards, that second drive comes in at 53 degrees on both of them. Okay, test number 2 complete. We've established 5,000 megabytes, and on our heat, minimum 32 degrees, cold boot, and we got 49 degrees. That's fascinating. That's a lot more consistent than the 53 degrees we had on the other ones. Okay, now, while this next test is running number 3, I'm going to show you the LEDs on the back of this card. I think a picture's worth 1,000 words. I'm only going to cut away for a minute so you can see the LEDs, so while the drive is working, you'll see drive number 3 is also working. Instead of looking through the I/O panel, trying to figure out the LEDs, they're actually labeled 1, 2, 3, and 4. I think the picture helps. So that was drive F. Let's go to drive G. 2 terabyte, 2 gigabyte, all, highlight, highlight. Let's see where we go. And I wanted to show you the back of the card so you can see the LED right there on drive number 3. And each one of these, 1, 2, 3, and 4. See that little dot? That's a little easier there. Better clarity so you get an idea what you're looking at. 1, 2, 3, and 4. Hope that helps. I never did point that out on the other drives. I didn't see any point in it. It was kind of like looking at the LEDs on the Supermicro card. You just had to look down inside and know it was flashing. Now this is interesting. Drive number 3 comes in a little bit slower. We don't know yet about the temp. So ASRock's design solution for being closer for the M.2 drive to the x 16 connector, such as it is, so much for that. Excellent. Test number 3 complete. We came in at just under 5,000 megabytes, but pretty close. And we topped out at 47 degrees, which is good. Let's look at the chart. Number 3 for the Sabrent Rocket on the Asus, 49. Number 3 on the Gigabyte Aorus, 53. So coming in at 47, I like that. Drive H, 2 terabyte, 2 gigabyte test file, all. Highlight, highlight. And that drive has come in respectively at 45 and 53. A little bit better on the speed too. And test number 4 complete. We started at 32 degrees, cold boot, and we ended at 44 degrees. Well, that's fascinating. Huh. Take a look at that chart again. Drive number 4, 45, and 53. And we came in at 44. Well, that's the most consistent we've had yet. I'm surprised, pleased, and impressed. I felt like it was a superior design, and I wonder, you know, everything's up for conjecture. I have a lot of wonders. My greatest concern has always been, and I've mentioned it in comments, but I haven't said in the video, that when you do the math, you add up all the power requirements for all these drives, you got to have a power tap on there to get enough power because you're sucking a lot through the bus. And having that extra power connector on the card, I think it helps. Now, I still think Gigabyte has the superior design for a heatsink, but based on the temps we're getting, you know, I've always said we've learned enough about the heatsinks to throw everything that we think we know out the door. And there's another good example. We got 4 good temps. We got 2 more to do now for the next part. So what we got to do is a screen capture. Wow, 44 degrees. Tap the power button. Windows will shut down. Once the computer's off, we'll turn it off. Hold the power button, drain it. Drained. Remove power. Remove the card. Wow. That's fascinating. Now, for those that want an updated copy of this chart, next video. Absolutely fascinating results. You never know what to expect. By weight, this is a very lightweight card too, with everything that's here. I'm amazed. Okay, and we'll be going for positions 1 and 2, and the same thing for the WD Black SN850 and the Samsung 980 Pro, right there. This will secure those other 2 drives, which are Sabrent, on the Supermicro Dual M.2 NVMe adapter, and we'll set that aside until the next test. We'll get these 2 drives set, heatsink back on, and do our test. Now the fan on this card is not objectionable. Do I hear it? I cannot tell the difference in this fan, the MOSFET, or any of the other fans in the case. Now, if I got 2 of these, 3 of these, or 4 of these, would I hear it? Only one way to find out. Shadow of things to come. Okay, all 4 drives are secured. WD Black SN850, Samsung 980 Pro, and 2 Sabrent Rocket 4 Plus. So these 2 are PCI Express 4.0, first generation. These 2 are PCI Express 4.0, second generation. These 2 are each 2 terabytes. These 2 are each 1 terabyte. So these are the only 2 we're going to test when we get that point. Put our sandwich back together. Heatsink is secure. We're good to go. Back in the box with the second part. Card is secure. Get the power tap back on. Plug in power. Turn on. Energize. Power to the video card. Power on self-test. We're seeing the BIOS codes. And we'll hear a post when the PC speaker makes its announcement. And then once we're up, we don't need to go into BIOS and check it. We'll just go right into Windows, verify the drives. I hear post, and run our test. Windows flag E, this PC. I'm moving a little fast, waiting for the drives to refresh. They haven't yet. Press F5. Yep, there they are. Just need to wait a minute. Okay, drives have come up. They're now recognized. WD Black SN850 is D, and the Samsung 980 Pro is F. Hardware info, sensors only. Scroll down to our drives so we can read the thermistors. There's the Seagate FireCuda 520, which is the boot drive. There's the WD Black SN850, 1 thermistor. The Samsung 980 Pro with 2 thermistors, and as it's been pointed out, thermistor number 2 is the chipset controller. So we're going to start with the WD Black SN850. We're starting off at 37 degrees for a cold boot, and we're going to watch from our minimum, maximum, and average. Let's see how hot it gets. Crystal disk mark, D drive, 1 terabyte, 1 gigabyte test file, all. Highlight. And to reiterate, both these drives we're now testing have both had their firmware update. We did not have to do it for the Samsung, but we did have to do it for the WD Black, and I still am a firm believer that the WD Black needs another firmware update to work on the Gigabyte card. That test is complete, and we topped out at 58 degrees. 58 degrees compared with the WD Black SN850 on the Asus at 50 degrees, and the WD Black SN850 on the Gigabyte Aorus at 58. That's absolutely fascinating. And if you notice on our speed on the read on the megabytes, we've established that we are just over 7,000 megabytes on the read. We took a performance hit when we were on the Gigabyte Aorus. We were just a hair under 7,000 megabytes after we did the firmware update to restore performance. So hold that thought. We got one more to test. Drive D, drive F, 1 terabyte, 1 gigabyte, all. Highlight, minimum, maximum, and average. Let's see where we get with the Samsung. Now, while we're waiting on that test to complete, on the Asus Hyper, the Samsung 980 Pro is 49 degrees, and on the Gigabyte Aorus, the Samsung 980 Pro is 61. Quite a spread. We have the most consistent reading on the cards, I think, with the Sabrent Rocket 4 drives, which are PCI Express 4.0 first generation. When we get into the PCI Express 4.0 second generation, that's where the temps really kind of run wild. And that test is complete, and we top out, can you believe that, at 50 degrees. That is most fascinating. When we look at the results, on the Asus Hyper M.2/16, the Samsung was 49, and on the Gigabyte Aorus, the Samsung was 61. And here we top out at 50. Well, the numbers seem to be most consistent on the ASRock card. And if somebody were to ask which one of these would I pick, I think the takeaway from this, picking an M.2 quad card is kind of like picking a motherboard. You know, change one thing, changes everything. Let's go back and look at the numbers one more time. And we also established here on the read, because the Samsung 980 Pro is just a little bit slower, but it's almost 7,000 megabytes on the read. Gets a good number on the write, just under 5,000 megabytes. Solid drive, both of them. And we can see our temps here, 58 degrees and 50 degrees. The WD Black SN850 runs hotter, but it also runs faster. And this piques my curiosity, because as we're looking at these drives, okay, PCI Express 4.0, first generation, second generation, and third generation. The PCI Express 4.0 third generation, specifically the Seagate FireCuda 530, is supposed to be good for 7,300 megabytes on the read and almost 7,000 megabytes on the write. My expectation, it would be just a little bit hotter, but you know, we get a chance to test one. Shadow of things to come, we'll see. Now the next step in the process would be to probably test the other ASRock card, but what we've established is this is PCI Express 3, and we have demonstrated with PCI Express 4.0 drives how that works, where your bottlenecks are at. And we've also seen where the performance is at and where the heat's at. And back to the question I mentioned a while ago about which one's better, it depends. If I were putting one card in a machine, I would probably buy the same brand as the motherboard I'm using. If I were putting 2 cards in this machine, whatever it is, it would depend on what drives I'm going to use based on what we've seen. And if I were going to put 3 or 4, I would want, again, for consistent performance, same brand. Same brand drives, same brand M.2 quad cards. So this next one we're going to do is the Amphitech Squid, which allows us to do 6 drives. So I want to thank you for watching. My name's Gil Boyd. Welcome. We're on to the next video. We're out.